I like puppies. It's time to chill out and get ready for a mediocre Q&A live stream. If you're old enough, grab yourself your favorite adult beverage, and if you're not, stick with apple juice. Put your feet up and relax. If you have any questions, feel free to ask them in the chat. And now let's cue up the intro music. What is up? Hello, my viewers. I know, that's probably getting old. I always do that, but I like Dr. Zarkov. I miss the guy, right? I don't know about you guys, but I used to watch that guy all the time. He was so corny and so cheesy, but I liked his videos. He was a cool dude. I think he was like an HVAC instructor or something like that, and then he just made videos at home. But I think he had a business too. I don't know. We should have It's sad because I think a lot of those people would not come on the Overtime show, but on the Overtime show, we have the perfect platform to interview these people. Maybe I should start doing that on my channel. Maybe I should start interviewing people. Maybe they wouldn't be as intimidated. Because like the Overtime show, it's fun, and you know, the people who know what it is, if you guys don't already know, HVAC Overtime, the YouTube channel, myself and my friends, we do a live stream on Friday evenings. But anyways, it can be a bit raunchy at times. It can be a bit educational, just a little bit, not much, just a tiny bit educational, but it's more or less just four guys, you know, just like sitting at the bar talking about whatever. So it's just cool. But yeah, we should have someone like Dr. Zarkov on. It'd be kind of fun to like interview a bunch of YouTubers. Speaking of YouTubers, you know, I don't get involved in a lot of drama and stuff like that, but there's a particular YouTuber. He's one of the biggest ones, and he had posted something on social media or something like that yesterday, and I politely chimed in and was like, hey bro, you're a little bit incorrect. And then I said, you know, I wasn't being rude at all. I was like, here's some information that's a little more factual. And I could tell that I hurt his feelings because he came back with like he was lashing out at me comment saying like, I think you've been in the walk-in freezer too long, you don't know what you're talking about. And then I posted some more information and like a picture and more factual information, and then he just blocked me and deleted me, so I can't see his stuff anymore. I'm not a person that goes out and attacks people. Like, it's just kind of funny, but I'm not even going to mention him because I don't need to give him any more attention than he needs. But yeah, it's a bit silly. So, but yeah, I'd like to have more YouTubers and stuff and talk to them and get to know people. So is that a toupee? No, this is my real hair. Most people don't know that I actually have hair on my head. That is my real hair. Here, I'll make it easier for those that don't. You know, I could put the hat on. You know, there we go. Whoa, oh, it's my secret identity. You know, but now for real. All right, so let's see what else we got going on in here. I'm looking at the chat right now. Hello to everybody. It's cool to see all you guys. I know I've missed a few. I'll talk about that here in a second. Reading through here. Let's see. Do I watch the Mikey Pipes channel? I've watched his videos once or twice. Honestly, I really don't watch very much YouTube content. It's hard enough. And so let's get into this. Someone had asked in the chat, how do I balance work and home life? Well, let me one up that question. How do I balance work and home life and then also start a social media business that has to do with work that takes up all my home time so I can focus on my social media business at the same time? How do I do that? I don't, okay? The only advice I can give to everybody is find a spouse that appreciates everything and tolerates your madness, okay? Because that's the only way that I get through all this, is that my wife, Jill, tolerates my madness, because I'm a whack. I'm a nutcase. I'm super hyper-focused. And yeah, I don't know why she puts up with me. Thank goodness she does. If you guys don't already, you should follow my wife on social media. It's at HVACR wife on Instagram. I think she has something on Facebook, but I don't think she posts very much on Facebook, but she definitely posts on Instagram. And she just kind of posts. So if your spouses want to follow, she just kind of gives ideas into how we live the HVACR life. And it's just a way to communicate and stuff. So we're probably going to take it further someday, but you know. All right, let's see what else we got going on in here. So how do I, I don't know how we balance it. It's chaos, okay? And that's also part of the reason why I haven't had live streams for like 3 or 4 live streams, is because I've realized that I need to prioritize some things, and my sanity is most important above all. And I'm sure there's some kind of a weird diagnosis there as far as all the craziness goes, but like, I'm a very hyper-focused person. And if I miss, or potentially am going to miss, a live stream, I lose my mind. Like, I start stressing out and I start just going crazy. And I know people out there will email me and say, don't take it so seriously. I'm trying, but I have issues and it's really hard for me to let go of things. Like, I just tend to focus way crazy on them. So, I've been trying to get better at that, and I've been trying to relax a little bit more and not be so stressed out if I have to miss a live stream. You know, it just is what it is. And I need to focus on my business too, my HVAC business, because that we're struggling in different ways too, because obviously we're short staffed and all that stuff. So it's kind of chaos right now. So it's just life. And, you know, we all have issues. I doubt that any of my problems are any more severe than anybody else's. In perspective, you know, it all whatever. But so hello to everybody. If you're new here, welcome to the live stream. This is the HVACR videos live stream. I'm a bit crazy. My name is Chris. Welcome to the chaos. Okay. So let's see what else we got in here. Commercial Kitchen Chronicles. That's Mr. Pat Finley. Pat is working on, well, he has launched a new podcast. He's social media stuff. He's going to focus on the kitchen hot side equipment, some refrigeration side. And then also I saw his post that he wants to kind of showcase other trades and kind of, you know, bring more light to the blue collar lifestyle when it comes to all the different trades. So you definitely want to check out Commercial Kitchen Chronicles. Pat's a cool dude. I've communicated with him a bunch on social media. I actually got to meet in person this last year, or a couple months ago. So let's see. What are the main things to be concerned about when installing a walk-in cooler? Well, let's jump right into this, because I definitely have that as the first thing that I want to talk on my topics right here. Okay, so first and foremost, walk-in coolers in general. Okay, walk-in coolers, the most important thing, the absolute most important thing, is properly sizing your equipment for the infiltrating heat load of the box you're going to be cooling. Okay, properly sizing your equipment is going to affect the entire operation of everything. Okay, it's going to affect the indoor humidity inside the box. It's going to affect short cycling. It's going to affect compressor life, product life, right? Because you want to maintain product temperatures, whether it be a refrigerator, a freezer, who knows, you want to maintain that temperature. And in the past, we used to oversize equipment. It wasn't right, but we were able to get away from it, or get away with it, okay? But that doesn't happen these days. There's a lot of issues going on There's a lot of regulations. We don't need to say whether we like the regulations or not, but they're here, okay? We can whine and complain about all of them, but the simple fact is that we either learn to live with the regulations and work with them and benefit from them and profit off of them, or we just complain about them and then end up out of business, okay? So we have a lot of new regulations that are attacking the walk-in cooler and walk-in freezer sizing, especially of the smaller walk-in coolers, 3,000 square feet or less. There's new Department of Energy regulations that are making manufacturers follow certain energy guidelines. They have to meet certain criteria. With that being said, oversizing your equipment isn't really going to work anymore, okay? Because you're not going to meet that. But then on top of that, if you're oversizing your equipment, even more so nowadays, you're going to run into operational problems, okay? Because if you have a massively oversized compressor and it's just going to start to a domino effect that's going to affect the entire operation of the system. So the number one thing about walk-in coolers and walk-in freezers is make sure it's sized right. Okay, as a service technician, this is going to be hard, but this is how I've learned to approach this. When I go into a walk-in cooler, walk-in freezer call, I will analyze it. I'll look at it. I'll be like, this is brand new equipment. And then I'll go and ask the customer, hey, have you been having this problem since this equipment was installed? Well, yeah, actually we have. Boom. The first thing that I'm going to do is do a vitals, just walk around, look at the equipment. Then I'm going to do a load calculation on the software. There's several different manufacturers out there that will allow you to do load calculations on your phone. Heatcraft has one. You can download the hub from Heatcraft. I believe you can do the full load calculation on your phone. Heatcraft RPD.com, I believe. But do a load calculation. Find out if the equipment is oversized or undersized. That's where you're going to start, okay? And then from there, you're going to move forward. Now, you find out it's oversized, okay, so then we got to start thinking about the repercussions. Now, what can happen if your evaporator is sized for the box, but your condensing unit is massively oversized? That is dramatically going to affect your evaporator TD. Your evaporator TD in the light commercial refrigeration side, let's define evaporator TD. We talk about the suction saturation temperature, but even that, I'm going to give you a caveat, okay? Single component refrigerants, we're going to look at the suction saturation temperature compared to the actual box temperature. And that is going to be how you're going to calculate your evaporator TD. So it's a comparison to the temperature inside the box and the suction saturation temperature of the refrigerant. But remember I said single component refrigerant. You start adding in blended refrigerants, especially the newer refrigerants that have a really high glide, and you actually don't just use the suction saturation temperature. You want to look at the midpoint temperature of the glide, okay? So a lot of these new refrigerants, the way that they're able to make them is by mixing together a bunch of different refrigerants, and they have a high glide, and that glide will affect your evaporator TD if you don't know how to measure it properly. So if you're looking at the dew point on your pressure temperature chart, which is normally how we would calculate superheat, which still is, but if you look at your dew point, that may not necessarily be your actual evaporator temperature if you have a high glide refrigerant. So you need to look at the midpoint of that glide to calculate your evaporator TD. And then that will help you, okay? So now I had a question on here about evaporator TDs and how it's affected by glide. I want to explain something too, okay? On my side, the light commercial side, we don't have capacity control. We don't have variable speed compressors, okay? We don't split, or what do you want to call it? We don't have multiple condensers so we can shut down one condenser. We don't have so with that being said, we typically design for the hottest ambient, okay? Now, I live in Southern California, out in the desert, okay? Some of the areas that I work in can be 115 to 110 or 120 degrees in the summer. And so we have to design our equipment for that high heat load, right, of the summer. But the problem is if you have a single capacity compressor, meaning it's not variable, okay, that compressor is now probably going to double in size when it cools off and we go to our 50-degree winters. You're still going to have that 2-horsepower compressor in the summer is now going to turn into maybe a 3-horsepower compressor, okay? And it's going to be pumping its little heart away, but it doesn't have the outdoor heat load, right? And so your liquid saturation temperature is going to be a lot lower, and that's definitely adversely going to affect your evaporator TD. So it's so important to understand that, because as service technicians, I go out in the middle of the winter on a single component or a single compressor system, and I'm like looking at my gauges going, why is my suction temperature suction pressure so low, right? My saturation temperature so low. And it's like, well, start thinking about it. Well, this compressor is now massively oversized. It doesn't have a heat load to overcome because it's only 50 degrees outside, and that's adversely going to affect your evaporator TD. Okay, so it's really important to understand that. I'm going to look at the chat and see what we got going on in here. I know I'm probably going off on a tangent. So, have I ever checked out Century refrigeration equipment? No, never heard of it, bud. Do I watch Mikey Pipes? No, I already talked about that one. So, okay, cool. I'm not seeing anything that I'm missing as of yet. So when it comes to our evaporator TD, let me preface this with saying too, I was actually just talking with Brett Wetzel from Advanced Refrigeration Podcast about this too. I plan on doing a more in-depth video because oftentimes when people ask me questions, when I'm working, and I don't know if it's the same, I'd like to know in the chat if it's the same for you guys too. But really quick, Matteo, I don't know if that's how you pronounce your name. Do I think R448A will ever be replaced with something new? Yeah, R448A is already on the chopping block, dude. Every refrigerant that you are using today is already on the chopping block. They already have a date for when it's not going to be used anymore. So don't get used to any refrigerants, okay? It's just because they're all being phased out, right? And if the hippies have their way, we're not going to use propane. We're not going to use water. We're not going to cool anything, okay? Because it's just going to be a problem. So now I lost my train of thought there. Let me see. Chris is looking a bit like Sean Penn. You're not the first person that's told me that in my life. That's kind of funny. All right, so I lost my train of thought. I know I was talking about evaporator TD. Oh, so yeah, I plan, and I know this isn't my normal style, but I'm going to start working on some things from the back behind the scenes, and I'm going to start contacting some manufacturers, and we are going to try to make a change with the manufacturers, okay? And the point that I'm trying to make is I've done a bunch of research, and I can go to all these different refrigeration manufacturers, whether they manufacture components, equipment, refrigerants, and if you ask them a single question about midpoint temperatures or when to use those, each one of them will come up with a different answer. So we cannot get a concise answer from everybody. We're going to work on that. That's one thing that I have the ability, and a lot of the other influencers, I don't care for that word, but it is what it is, right? A lot of the other influencers and or educators on the YouTube area, we have the ability to contact these manufacturers and help to create some change and voice concerns that you guys have to them. So I'm going to do that. I'm going to take it upon myself to contact them. We're going to try to come up with a video that explains all of this really in depth. That's not too boring, right? And that's something that I've had a talk with manufacturers before too, because I'll have a manufacturer and they're like, hey, let's do a video. Let's make this. And I'm like, guys, you got to dumb it down, right? Because I don't like hearing all these big words that I have to like read 4 times to understand what they mean and different things like that. I'm just a knuckle busting mechanic, and I like things to make sense. I like to dumb things down because oftentimes it takes a while for me. I have to learn it at, like, when I say dumb it down, I have to slow it down and break it down and learn it slowly. And then I can get to the big words and the big definitions, and then I can understand it. But I have to start with the dumbed down version and work my way up. So I'm going to try to do that and try to make an effort to make a video about the entire load calculation process, when and where to use the midpoint temperature of a glide, when and where to look at evaporator TD and how it affects things. So we're going to do that, and we're going to talk about it more in depth. So Will Speed, again, thanks for becoming a supporter and being a supporter for so long, but I really appreciate it, man. That's really awesome. All right, let's see. Let's see. Brett says, let's have a cage match between the refrigerant manufacturer, the engineers of the equipment, and the customer, and see what they all think about TD and superheat. That's a good idea, Brett. We should do it. All right. So let's go ahead and do this too. Couple things I want to talk about. So I did make stickers. They're not available yet. They've been I've been popping them in little different pictures and stuff. They will be available soon. I've got a bunch of them. Honestly, I am just so overwhelmed with life right now and work and this that I'm trying to prioritize things, and stickers are on the back burner. Merch is on the back burner. If I'm out of stock, I'm out of stock until I have time to sit down and order it. I'm never planned on doing merch and merchandise for those that I triggered by saying merch. You'd believe how many emails I get because I called it merch in a video? Oh my gosh, people start losing their minds. Call it merchandise. It's like, shut up, okay? But merchandise, merch, stickers, hats, beanies, sweaters, those are like, I never planned on doing any of that stuff. Honestly, the first time someone asked me, I was like, that's weird. I don't want to do that. You know, it's just not my thing. Now, I did, inevitably, and I appreciate all the support that all of you give. And it actually gives my wife something to do, because that's not that she doesn't have a million things already to do it. That was a bad way of me to say that. I need to be a better husband, right? But no, she handles all the merchandise, packaging, and shipping and all that stuff. So you can keep her busy if you guys place orders. So, wanted to... Again, I'm losing my train of thought like crazy right now. Why am I losing my train of thought? My brain is just like doo-doo right now. So I'm sure I'll remember what I wanted to talk about too. So I wanted to make an effort to, and I need to get better at doing a lot of this stuff, but I've been getting a lot of packages from people, and I'm going to make a better effort of showcasing the stuff that people send me. It's very, very awesome. I'm very humbled that people want to send me old tools and different things like that. And I'm very honored to be able to do that, okay? So thank you very much for those that have already, or, you know, various little things that people have sent me. It's amazing and awesome, okay? So I know I don't acknowledge you guys enough, but thank you. And I know I don't acknowledge my supporters enough, but thank you very much. I'm just trying my best to, like, keep my head above water from drowning over here, because I'm just going crazy. But anyways, I got some new cool tools that I kind of wanted to talk about really quick. Now, I've talked about this one before. Okay, this is a refrigerant leak detector from Robinair. This was actually given to me, and all these tools were actually given to me by the same person. So I'm going to hook him up with a shout out and give him a plug, because he does have a product that he wants me to talk about. So I have nothing to do with this guy. The gentleman that sent this to me is Chris Eads. Now, he gave me this at the HVACR School Training Symposium. This is probably one of my favorite tools that I've ever seen in my life, this Robinair leak detector. Now, this is from the 70s, I believe, from my research. But he also sent me some other old school leak detectors, which I did think were really cool. This is one of them right here. It's just kind of funny to see these things, you know, how old school the technology was. And then also he sent me this one right here. Interestingly enough, this has the same tip as that little one that looks like a ray gun too. This one's made by Thermal Engineering. So this one's pretty cool. So thank you, Chris. And I will talk about Chris's product. Now, it has nothing really to do with me, so I can't really showcase his product on my channel because I have no way to showcase it. I make service videos, but Chris made something called the ACEZT. So it's ACEZT.com. And what he did was he made these are 3/4 inch plumbing tees. They're for residential is really the application you can use them for. And they have a cap on them. And when you pull the cap off, you're like, what the heck does it have a cap for? Well, it's actually a pretty smart design. What he came up with is these little tools right here, right? Now, this one has a hole on the side, okay? So if you think about it, if you want to blow this tee out, but you don't want to have to plug this side, you take this right here and you put it in there, and now it just blows out the side and it doesn't blow out the bottom. Pretty cool little idea, right? And then he also came out with one that you can screw a nitrogen adapter into right here, right? And you could blow it out with air if you wanted to. So I thought that was pretty cool. But it's ACEZT.com. Check him out. Give him some support. Tell him I sent you over there. I got no affiliation. He's not paying me or anything like that. He just sent me a package of these, and I kind of feel bad because I can't use them. I don't do residential. I'll keep them, and I'll find a way to use them at some point, or I'll give them to a friend or something like that. But pretty cool. But yeah, I do want to say thank you to Chris Eads. That was really cool of you, bud. Okay. Oh, that's what I was going to say earlier before I lost my train of thought. So for those that have been emailing me to try to help support the channel, obviously I work with TrueTechTools.com, and I have an offer code set up with them. Big picture, one word. You get you an 8% discount, and I get a small commission when you use the code, okay? So in the past, I would do affiliate links with them, and then I would also do offer codes. there's no need for the affiliate links. So if you guys are emailing me asking me for affiliate links anymore, don't worry about it. Just use my offer code. We're good to go. Okay. Because the affiliate links were taking me way too much time to generate, and because I had to make a different link for every tool, and it was just too time consuming. So I eliminated those, and we're just going with the offer code now. So if you want to purchase any new tools and you want to help to support my channel, check out TrueTechTools.com. If you like what they have, if you like their pricing, use my offer code, big picture, one word. You'll get an 8% discount. I get a commission. We're good to go. Okay. All right. Let's see what else we got going on in this chat right now. I'm just going up here. Can you use a 3/4 horsepower condensing unit for 3/4 ton reach-ins? Corey, it really depends on the temperature of the regions and the capacity of the condensing unit, what ambient is going to be in. Because if you have a 3/4 horsepower condensing unit in 120 degrees, the delivered BTUs out of that condensing unit are going to be significantly lower if that condensing unit 3/4 horsepower was installed in a 50-degree ambient. The BTU output of that condensing unit would be through the roof, okay? So it really depends on the load of your space that you're trying to cool, so where the evaporators are. And 1/4 ton doesn't mean a whole lot. We rate in BTUs, okay? So just because it has a 1/4 ton TXV doesn't mean that it's going to be a 1/4 ton system, so keep that in mind. But it really depends on the load. So can you? I don't know. You need to do the math, okay? But what I will tell you, oftentimes people forget, especially in the light commercial side, is line set length, okay? Line set length makes a huge difference when it comes to refrigeration equipment. First off, if your line set's way too long, you could have pressure drop issues, which could lead to oil return issues and capacity issues of your equipment. Compressor cooling could go in the gutter. Most of our equipment is cooled by suction gas coming to the compressor. So that suction gas has to come back at a certain velocity and a certain temperature to properly cool off the windings of that compressor. And if it doesn't do that, you can run into overheat situations and have issues, right? Okay, so could you use a 3/4 horsepower? It's hard to say, but you need to do the load calculation on the equipment. I highly encourage every one of you to start learning how to do load calculations, because just like we are short-staffed, supply houses are short-staffed too. Trusting supply houses to do a load calculation for you is a gamble. You might have an amazing supply house that does a great job, but then you also might have a supply house that just trained a technician or trained a counter guy to do a load calculation, and he doesn't input the numbers right. And that could drastically affect your equipment, okay? That could lead to oversizing or undersizing. I'll give you a perfect example. I got called out to a cake shop, right, where they made wedding cakes. And I was a second opinion because they had a general contractor come in, and he had a load calculation done, because that particular general contractor, he was not a refrigeration guy, but he had an AC guy. Okay, he told me, I got an AC guy and I have an account at the supply house. So he called the supply house, the general contractor, said this is the box that he wanted to refrigerate, and they did a load calculation, but he didn't tell him what they were keeping in the box, and he didn't tell him what kind of humidity levels he wanted to be maintained in that box. And so because the equipment wasn't sized right, it was cooling just fine, but the humidity control was problematic. It was way too humid in that box, and it was affecting the way that the cakes were cooling after they iced them, and it was just causing a catastrophe. And so they called me in as a second opinion, and I'm like, yeah, you guys got some serious problems here. Let's start over. And the general contractor's like, no, my AC guy says he can fix it. And I'm like, well, then why am I here? My AC guy says it'll be fine. Where's your AC guy at? Well, he's on vacation. Yeah, exactly. Okay. The equipment wasn't sized right because they called the supply house. They didn't ask the right questions at the supply house. There was a loss of communication somewhere, and the equipment was incorrectly sized, and that led to all of their cakes being ruined in a consistent basis, and that was just pissing off the business owner, and it was just an issue. So you have to do load calculations. We as technicians need to learn how to do those load calculations ourselves, so that way we can verify when information is incorrect. Just like I say, and I said recently on a video, digital tools. I love digital tools. I love using apps that consolidate all my measurements onto one screen so I can stare at it and say, boom, 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 this is what's wrong, okay? It's amazing. Digital tools are amazing. We can take field piece job link clamps. We can take a field piece S-man manifold like I have down there, and we can clamp them on systems. We could take this one right here. This is the JL3LC. This is the large pipe clamp. This thing goes up to 4 1/8 of an inch on pipe. So if you're working industrial, heavier industrial supermarket stuff, these things are badass and they're wireless, all that stuff, right? But if this is put on the wrong pipe or the wrong area of the pipe, and we have a novice technician that doesn't know how to differentiate between where it's supposed to go, and it gives him an incorrect measurement that's just off by a few degrees, but then in the grand scheme of everything, it messes up everything. So if we as technicians don't know how to interpret the data from our digital tools and our apps and all that different stuff, and we don't know how to say, hey, this isn't right? This doesn't seem right, because we can't just blindly trust an app because an app tells us to do something. That's not how this stuff works, because sensors are wrong, transducers are wrong, all kinds of stuff, okay? We're working on a Heatcraft intelligence system or a Heatcraft QRC system or a beacon system, right? And, the board says the superheat's perfect. Well, guess what? Maybe someone was working on the system and they overpressurized it like I did, and they're an idiot like I was, and they ruined a pressure transducer, and so then it's rating 35 PSI off, just like I did in one of my videos. It was pretty funny. That can lead to a headache. Oh, but the board says that the superheat's fine. No, we need to verify, because what happens if there was an idiot there before you? In my situation, what happens if I was the idiot, right? And I messed up a pressure transducer and made it read 35 PSI off because I overpressurized it. Okay, so we have to know how to interpret data and know when it's right or wrong. Okay, so the apps, all that they do, and the digital tools, they consolidate information for us and they put it on one screen, and they make it a little bit easier because we now can get on the fly superheat measurements. Did you know? See, when I was coming up in the trade, I learned how to measure superheat with an analog gauge set, looking at a pressure temperature chart. Actually, I never looked at the analog gauge set. I had my little pocket Tecumseh pressure temperature chart. Those were my favorite ones too, by the way, that folded like on 5 places or whatever. Those were awesome. But I used to take a pressure temperature chart. I used to tape a thermocouple. Actually, not even. I started with a analog thermometer, right? And you tape the analog thermometer to the suction line. You'd insulate it and take a measurement, and you'd be like, oh, my superheat's 15 degrees. And then guess what I would do? I would take the superheat while I was charging that air conditioner maybe 3 more times in the next 2 hours while I was charging it, right? Well, guess what? Superheat is a fluid number. It doesn't just sit there at 15 degrees and stay there, okay? It changes every second. Digital tools give us the ability to measure that and see that in real time. So digital tools are the future. They're not going to replace us. They're not dumbing down the industry. Those people out there that say digital tools are dumbing down the industry, dude, you need to take a step back and look, because they're helping us. They're giving us the ability to see more real-time information. Someone, and this is what I'm kind of going towards another path, but this is leading me to this. Someone in the chat asked me if I do a triple evacuation, okay? And again, I'm going to the... Well, I'm not even going to say that, but no, I do not do triple evacuations because I have read a lot of information that have basically disproved the need for a triple evacuation. I'm not going to say that it doesn't do anything, okay? The idea of a triple evacuation, nowadays you start to pull a vacuum, you introduce nitrogen, you pull a vacuum a little bit further, you introduce nitrogen, you pull a vacuum a little bit further, and you do that 3 times, okay? In the past, we actually were told to use R22 refrigerant, right? Because R22 had a great ability to absorb moisture. This is pre-EPA protocols and all that different stuff. A lot of times people would do a triple evac and they would use R22 refrigerant. And actually that would do something because the R22 would absorb the moisture. But when we're using nitrogen, nitrogen doesn't absorb very much moisture. But what it can do is nitrogen can actually introduce warmer temperatures, which could help refrigerant and refrigerant essentially to boil out of the oil. Majority of the time when we're pulling an evacuation and we're really, really struggling, it's oftentimes oil that has refrigerant trapped in it, and that refrigerant is slowly off-gassing from the oil, but it's taking forever. So I personally don't do triple evacuations. In my opinion, the best thing you can do is heat up the system, okay? If you have a large compressor and you heat up the oil, turn the crankcase heater on, okay? Let the crankcase heater get that compressor nice and hot. Do whatever you have to do to warm the system up. Any places where there could be oil, warm it up So that way you can try to help raise the pressure of that refrigerant that's trapped in the system and help to move the molecules so that way it can be evacuated and you can get the vacuum in the system down, okay? If you want to learn more about evacuations, there's a really interesting book. It's called The Review of Vacuum for Service Engineers. Now, this book was written a long time ago, but it was actually just revised by Brian Orr from HVAC School and Jim Bergman from Measure Quick. They revised it together. You can get this book from True Tech Tools. I believe they're the exclusive distributor of this because I believe... Anyways, but yeah, truetechtools.com. And again, you can use my offer code Big Picture. This will give you a really good understanding of an evacuation and what a triple evac truly does. I'm not saying it doesn't do anything, but I think it's more of a, people don't realize what it's doing, because a lot of people seem to think that, when you introduce nitrogen, that the nitrogen is going to absorb the moisture and then it's going to help to move it out of the system. And I don't think that's quite accurate. I think what the nitrogen is doing is it's coming in at a higher temperature, and it's just kind of helping to move the molecules of refrigerant around, warm them up, so that way they can be pulled out a little bit better. So really, triple evac, in my opinion, is not really necessary if you have proper core removal tools, a good size vacuum pump, and most importantly, before the vacuum pump size is the hose size at which you're using to evacuate the system. I use the True Blue hoses, but there's other large diameter hoses too. That's really where you're going to get all your efficiency is from your hoses. Okay. My entire career, I've had a 6 CFM vacuum pump, but I only had True Blue hoses for the last 5 years. Okay, maybe something like that. And then before that, I had the large diameter Appion hoses. Okay. Before the Appion hoses, my evacuations were all being pulled through a manifold gauge set. Okay. Using my 1/4-inch process hose, my charging hose. Did you know, like, if you open this up, I want to say a 1/4-inch charging hose only allows less than like 1 CFM of, let me see if it says it right here. It's like less than 1 CFM of flow through it. So it doesn't matter how big your pump is. You can have a 10 CFM pump. You can have a 20 CFM pump, but you've got, it's like trying to suck a golf ball through a garden hose. Okay. It's just not going to happen, right? Because the hose is too small. So, you know, no, I don't do a triple evacuation. Hopefully that answers your question. Can we talk about the sweet, sweet Heatcraft sponsorship? I swear, half the comments, people lost their minds because I started that video out with this video is brought to you by Heatcraft. Yes, Heatcraft is a new sponsor. No, Sporlin is not gone. Sporlin is still my title sponsor to this channel. Occasionally, you'll see someone else pop up on the video because I'm doing a marketing thing with Heatcraft right now. So they did a series of videos. We're going to be releasing them throughout the year on different topics. And on those videos, it will say this video is brought to you by Heatcraft. Okay. So yes, I am working with Heatcraft now. They're cool. It's been great so far. So let's see where it goes. Again, one of the cool things about working with these manufacturers like Sporlin and Heatcraft and Fieldpiece and all these different ones is it gives me the ability to give them feedback. Okay. I just had a really good conversation with Fieldpiece and gave them some frustrations that I have. I didn't expect them to answer all my frustrations, but I was told that every single thing that I complained about is being changed. So, whoa, my mind was blown. I thought I was just sending them an email saying, hey, this kind of frustrates me. And they were like, oh, we appreciate the feedback. And so I encourage everybody out there, if you have frustrations, if you have ideas, reach out to these manufacturers. Now, don't be a jerk about it, but reach out to them and say, hey, you know what? This doesn't make sense and it might work better. Now, also understand that, you know, manufacturers aren't going to listen to everything you say because there's a lot more than just the functionality that you want it to work as, right? Because just because in my head, I do this every day and I work on ice machines and I need, you know, a manifold that has 3 probes on it, you know, when I'm doing evacuations, because I need to do a 3-point recovery when I'm recovering, right? But not everybody works on that kind of equipment, right? So it doesn't always make sense for these manufacturers to listen to every single complaint and or idea that they have, but reach out to them, okay? And it's cool. It's cool being able to have that kind of influence for sure. Yeah, exactly. Mike B. Mike B says he got that Eddie Murphy reference, golf ball through a garden hose. That's like nobody ain't gonna fall for no banana in my tailpipe, right? I'm stuck with a bunch of movie puns, and that's just a horrible thing. Someone had asked me recently how, and actually that's in here, how is it that I can remember random equipment info and service history from years ago? I'll just ramble off in a video and say, boom, you know, da 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 da, all this different stuff. The only reason I can remember all that weird crap is because my brain prioritizes work over everything else. It just does. I'm sure there's some sort of a, you know, Clive put a little Easter egg, Big Clive from bigclive.com, or Big Clive Live. Anyways, Clive had said something one time that he said something about technically minded people may, you know, he feels like a lot of technically minded people may be on the spectrum of being slightly autistic. And I'm very interested in that because I tend to notice that a lot of my friends that are technically minded and stuff, I'm not saying everybody's autistic, but I'm saying that everybody has unique quirks about them, right? And so, you know, we have like, I may be focusing on work and like hyper focused on everything, and I tend to forget about other things. Now, is that right? No, it's not. But that's just how my brain works. So that is how I can remember random crap. And that in movies. For some reason, I always remember movie references or movie quotes. Like those things are always there. Yeah, that's a whole argument with my wife about that one right there. All right, let's see what else we got in here. Yeah, if you have, yeah, please, I need to breathe for a second. Do me a favor and smash the thumbs up button, guys. It really helps out the stream. I'd really appreciate it. Have I ever changed the oil, then realized the compressor is bad? I don't know if I've ever changed the oil and then realized it's bad. No, but I've done major repairs on equipment, and then you go to start it up, and it's like, oh, crap, the compressor's bad, you know? So that's why I try to make it a point to, even if a system's completely flat on refrigerant, just go bump the compressor real quick to make sure it's not shaking all over the roof. Especially, like, I'm about to go and repair an air conditioner that had a cracked discharge line on it, and it's a scroll compressor. Anytime you have a cracked discharge line, you need to find what caused it to crack, okay? It's not very often that a discharge line is just going to snap or crack by itself. There's some kind of vibration in the unit. It could even be a harmonic thing from a weird frequency of a fan motor running or something weird, right? But it's usually something like that. So I'm actually going to go fix something. And when we walked up to a unit, my apprentice was out there. He diagnosed it as being out of refrigerant. He found a crack in the discharge line. And I said, find the vibration. When he said that, go find the vibration in the unit. So then we proceeded, and by then I was there, and we proceeded with walking around the unit. And the system was flat, but we went ahead and pushed in the contactor and just bumped the compressor for like 2 seconds, made sure it wasn't shaking. No, it sounded fine and it works. And then we found the indoor blower assembly was out of balance, and there was actually a crack below the indoor blower assembly on the metal that it mounted on too. So we found our vibration. More than likely, we found the cause of the cracked discharge line. So you always got to dig into that kind of stuff, and don't just assume the first thing you find is the problem. We were just having a discussion about that with my apprentice, where we went out and we found all kinds of problems with the system, and it started with something simple. I think it was an ice machine, and the touchpad wasn't working, right? And it was actually today. The touchpad wasn't working. Okay, well, we couldn't really do anything until we got the touchpad to work because we couldn't turn it on. Well, we pushed the power button enough times that it finally turned on. Okay, so then we got to go through the system, and we noticed the compressor wasn't running. So then we went on the roof, and we found it had a bad low voltage transformer, but we didn't just stop there. We started looking, and I looked at the evaporators. The nickel plating was coming off. Okay, so I added that to my list. I noticed that the ice probe, the thickness probe, the frequencies weren't right, and it looked really bad. So again, we don't just stop at the first thing, right? We do everything in our power within reason to investigate that system. So you have a bad compressor. And I actually heard Brian Orr say this on a podcast recently. And while this may be frustrating for some residential guys, I thought it was very interesting, okay? So Brian gave a scenario, and this is on the HVAC School podcast. I don't remember what podcast it was, but he gave a scenario of a technician walking up to a grounded compressor on a residential air conditioner. It's grounded compressor, okay? Okay. Can't really do anything because we don't know what caused that compressor to go bad. Now, we know something caused it to go bad, right? Because compressors rarely ever go bad by themselves, but we don't know what caused it, okay? But the thing is, it still had refrigerant in it, okay? So he encourages when you have a grounded compressor or a bad compressor and the system has refrigerant, to go ahead and recover that refrigerant and then calculate by looking at the line set length. Now, mind you, this is a residential split system, right? Calculate how much refrigerant that system actually needs. So then you know, hey, this system was low on refrigerant. So that way you don't come in, say, I need to quote a compressor. You quote a compressor, the customer approves it. Then you go to repair the compressor and, you know, you pull a vacuum, the system won't pull a vacuum. You find out it has an evaporator coil leak. So now they need to spend another $4,000, right? So you do your best within reason to diagnose the entire system. You walk up on a system that has a grounded compressor. Does it have refrigerant in it? Okay. Is it a system that you can verify that, you know, by a data plate that it takes this much refrigerant? So in that case, go ahead and recover the charge and find out right then and there. You can leave the tank on the roof for the person who's going to repair it or whatever, but you know that it has the right amount of refrigerant. Okay. So now you know it more than likely doesn't have a refrigerant leak. So you can safely quote just the compressor with a caveat that says, you know, once we replace the compressor, we have to further diagnose to find out why it went bad, but at least you've done your due diligence. Okay. So be a thorough tech. Someone asked me, where's the comment at? It was a gentleman named Frank, and I'm paraphrasing his criticism. Okay. And again, guys, I appreciate criticism. If you have criticism, that helps me to grow. Okay. Just don't be a jerk about it. But if you have something, if I said something incorrect, correct me politely. Come to me and say, hey, you know what, dude, that's a little incorrect, and give me some documentation that I can read so I can better myself. But anyways, Frank had given me some criticism that I was working on a walk-in freezer and it was iced up. And he said, you know, you didn't need to do everything that you did. You could have just de-iced it and moved on. Because again, when I first walked up to the walk-in freezer, I noticed that there was a bungee cord on the door. Those are a dead giveaway because they bungee the doors open and then they forget and then the coil ices up. Okay. So I saw a bungee. I addressed it in the video. I said, I wonder. And then it was iced up. We de-iced it. We couldn't find anything else wrong. But I tested the defrost heaters. I turned them all on and did a current test on every heater. I tested the defrost clock, made sure it held time. I came back another day, checked the defrost clock again. I checked the refrigerant charge too because I had marked the liquid level when I installed the system, okay? So he was mentioning that I didn't need to go through all the steps. I could have just de-iced it and moved on. Yes, I could have. But what happens if that bungee wasn't the cause? What happens if they weren't using that to hold the door open and there was a bad defrost clock or a bad heater? Guess what? You can have 4 heaters in a coil and only one of them go bad. It's happened. It's a pain in the butt, but it happens. Okay. So we have to do our best, even though this job may seem easy, even though it seems I just got to de-ice a coil. I do this all the time, right? Because you're a professional coil de-icer like I am. We still go through our due diligence. We still go through our checklist and we still make sure everything's working properly. Okay. That's what separates us from all the other crap. Okay. You want to be a better tech, be more thorough and efficient. Okay. Just because you're thorough doesn't mean and you're the best technician, but you take forever. Well, there's a fine balance there. Okay. Because you still have to be profitable for your company. You have to think like that. Okay. You can't spend 7 days at a job to install a door gasket. That's not going to be profitable whatsoever. Okay. Yeah. You may have done the best job ever, but it doesn't make sense. So you have to find that fine balance, but you need to be thorough. Don't make mistakes. Don't cut corners unless you can handle the repercussions of potential corner cutting. Okay. All right. So now that I've answered a million questions and I haven't been marking them off, I need to cross them off so I know. So I already answered that one. Let me see. I'm going through here. I already answered that one. I'll look at the chat here in just a second. Not that one. Brooke had asked me a question about Manitowoc ice machines, and he listed off a whole bunch of problems that he was having in his machines. But the first thing that he told me was these machines are filthy. And then he started listing this and that and this and that. I'm going to tell you right now, Brooke, if you have a dirty ice machine, you can't properly diagnose it until it's clean. Customers need to have that equipment cleaned properly, okay? Manitowoc, Hoshizaki, Scotsman, I'm calling them all out. Isomatic, Fullet, Vote, okay? Those are all the ice machines that I work on, okay? Or have worked on. Every one of those manufacturers has a cleaning guide in their service manual, and that cleaning guide says that you can clean their ice machines in 20 minutes, 30 minutes, 15 minutes, 12 minutes, whatever, okay? That is not the truth. Every one of the ice machine manufacturers, that's not an ice machine book, but every one of the ice machine manufacturers, I make it a point that and I'm going to challenge every one of you guys too. If you ever go to an ice machine service class, this is something kind of fun. You don't need to be a jerk about it, but start asking questions. Start raising your hands and saying, hey, how long should it take for an ice machine cleaning? And then when they give you that blanket answer of, oh yeah, our machine can be cleaned in 15 minutes, say, is that a full teardown? Is that getting rid of all the calcium on the evaporator? Is that pulling the hoses out and running nylon brushes in the hoses to get the slime buildup that nothing else is going to take off? Is that pulling the water valves apart and cleaning the calcium on the water inlet valve and the dump valve? Okay, no, it's not. Every manufacturer out there has published data that says their ice machine cleanings only take this much time. If you're working on a Hoshizaki ice machine, the ones that I work on are the big machines. So anywhere from 1,300 pounds and up, okay? A 1,300 pound Hoshizaki ice machine for a full teardown is going to take minimum 4 hours. Minimum. Sometimes longer, maybe even 6 hours, okay? 1,400 pound Manitowoc Quiet Cube machines, 2 of them sitting next to each other. Pretty much assume you're going to be there for 7 hours cleaning those machines properly. I'm not talking pouring cleaner in there. I'm talking pouring cleaner, breaking up all the lime, disassembling the entire machine, scrubbing down the entire machine with a damp towel and ice machine cleaner, hosing everything out with a hot water hose, brushing all the tubes, descaling the machine, then doing the whole entire process again by pouring sanitizer in there, running sanitizer through the machine, then starting the machine up, then watching the machine make 2 to 3 cycles after you clean it. That's the key to cleaning every ice machine out there, is watch multiple cycles after you clean it to make sure nothing funky's going on, okay? And take the time and do it right. So if you have ice machine problems and it's a filthy machine, obviously if you walk up and the water pump's not working, yeah, you can change a water pump and get them going, but you can't give them 100% this machine's good until you clean it properly, okay? So you have to clean those ice machines first. Once you get them cleaned and completely descaled, then you can put them back together. Now, on Brooks' comment in his thing, he was saying that he saw one of my videos where on a Manitowoc ice machine, I told him that the ice thickness frequencies, there's 2 frequencies that it measures on the thickness microphone. And it's, I said that they should relatively be the same. And that is true, okay? And his weren't. That indicates to me that he has a problem with his water level probe, but he also said the machines were dirty. So you got to get them cleaned first and then diagnose, okay? That's the most important thing you can do. So I answered that question. Let me see. I'm reading through the chat. Yes. Jason Johnson, 2 to 4 hours. He doesn't give, what anyone says to properly clean it, it takes time. And that is absolutely correct. They all take time. The countertop fullet ice machines. Oh my gosh. I worked on those for a good 6-7 years when I was doing work for a hospital. I worked on hundreds of those countertop fullet machines. They became one of my favorites. The Symphony machines. Those things are awesome. Little itty bitty guys. But good gosh, could those things get dirty. And good gosh, did it take a long time to properly clean them. One of my favorite things about the countertop and the wall mount, especially the wall mount fullet ice machines, like the Symphony ones, and I think Horizon, no, not the Horizon, because Horizon was the new one, but the Symphonies. One of my favorite things about those was that the condensing unit, the whole ice machine itself was a skid, and you would just undo a couple hoses and pull the skid down. So if you ever had a bad compressor or a bad gear motor, the particular hospital I used to work for, they used to have backup condensing unit skids. So if one failed, we would literally take the failed skid out, put it on a cart, bring a new skid up, put it in, and we could have the ice machine operating in 20 minutes and then go downstairs and fix the other skid and use it as a backup, because the dispenser was its own thing and the skid just slid into it. Those were great machines. I miss working on those, actually. Those were a lot of fun. All right. What temperature do I usually suggest for cook drawers? Well, you got to think about this. Let's assume they're a medium temperature cook drawers, okay? What temperature should they be? Well, realistically, not below freezing, okay? As cold as you can get them without going below freezing. But the closer you get to below freezing, okay, the more potential you have of the coils icing up, okay? And let's remember something. Well, wait a minute. How come you can have a refrigerator, medium temperature, right? That's only maintaining 37 degrees. That doesn't make sense. That's not below freezing. That could never ice up, right? Right? No. Okay. Because in order to have heat transfer, you have to have a medium for the heat transfer, right? And so as you circulate the refrigerant through the system, that refrigerant has to be colder, significantly colder than the air being pushed across it for the heat to transfer, okay? So you have to get the evaporator temperature, the internal temperature of the evaporator, actually below freezing when you're maintaining a 35-degree box, because on most reach-ins, you know, we're actually pushing higher than 15, 20 degrees for a TD, okay? That's a whole nother discussion for another day, and we do that for many reasons, but we can talk about that later. But so if you're maintaining 35 degrees in the box, your actual saturated temperature of that refrigerant more than likely is going to be 10 to 15 degrees, sometimes 20 degrees colder than the air temperature. So that means that your coil is now below freezing, even though the air that it's the temperature that it's maintaining is not below freezing, but the coil is below freezing. So you get frost particles that builds up. So to answer your question, what do I usually run Cook Stores at? About 38 degrees. If I can maintain 38 degrees box temperature, and the system's designed right and all the drawers shut properly, then the temperature should be fine. Any colder than about 37 degrees, you're going to start to run into the potential of freeze up problems where you have to add a crap ton of defrost throughout the day, which affects the box temperatures and all that stuff, okay? Now, it's really important to understand that reach-in coolers are typically designed with a higher evaporator TD, so that way they can bring maintain the temperature, and they know that people are going to be opening and closing those doors all day long too. Really important to understand whenever you're working on a reach-in cooler, unless it's a blast freezer, it is not designed to bring temperatures down. It's only designed to maintain temperatures. So customers, and I run into them occasionally, they think that they can cook chicken wings and then throw them in the refrigerator and it should be down to temperature. No, it's never going to get down to temperature, because that box is not meant to bring food down from 150 degrees to 37. It's only meant and designed to maintain a 37-degree box temp, give or take a couple degrees, okay? So the system would have to be engineered and spec'd to be a blast freezer, which a blast freezer is actually designed to bring food down to temperature in a certain period of time, okay? So if a customer wants to rapidly cool their cooked food, they need to get a blast freezer of some sort. And a blast freezer is going to take product temperature. It has probes all over the place. It's a massively oversized system. And the manufacturers have designed it for short run times. They know this system's not going to run, and it's going to run in short amounts of time, and they have all kinds of capacity control and different things inside of it, okay? Let me see what else we got in here. Was there any bent fan blades on my recent walk-in freezer video? I don't think so. I don't think so. The one that was iced up and it was making that noise, yeah, I think once I turned it on, it was fine. Sometimes I may have straightened them out. That video was actually made a couple months ago, so it was a long time ago. What kind of deviant puts chicken wings in the freezer? I don't know. Who knows, man? Go to some of the restaurants I work at. Blast freezer is pretty cool. You've worked on a few of them. Yeah, I've worked on one or two of them, Jason Johnson. And last guy, hope you heard the answer to my question about the evaporator TDs and stuff. And I'm going to make a full video on that, but I addressed it in the beginning. Let's see what else. This was an interesting comment to get all like feely and everything, right? I had an anonymous commenter. The reason why I say anonymous, because it was just a screen name and it was a weird screen name, so I'm not going to try to pronounce it. But I had an anonymous commenter say that my videos make him feel like he's not alone out in the field. And that's pretty cool, because I could appreciate that. Oftentimes, if you're a technician like us, right, before the internet, oftentimes, you know, we would run into a technician maybe here and there at a supply house, but it wasn't like we got to talk to each other like we do nowadays, because we have social media. So I could imagine that for someone doing HVACR, kind of the little niche that I'm in, like commercial restaurant work and stuff, it's probably pretty cool to see videos of someone doing the same kind of work that you do, because, you know, you get to see like, oh, damn, I'm not the only person that made that mistake. You know, you get to see other people and you get to see that, you know, they're just like you. And I hope that that comes across, because when I first started making my videos, you know, the first like one or two, I was very critical about putting mistakes in the videos. And I was like, wait a minute, I didn't feel right? Because it was kind of like, you know, I felt like a fraud because I can't edit out my mistakes. So now I've learned that, like, you know what? I'm real. And I'm human and I need to show those mistakes. So that way you guys can realize that like I make them too. But the important thing is I usually try to figure out how I could have done it better, or I correct the problem, right? So it's a matter of that separates you from everybody else, because everybody makes mistakes. But what do you do to fix those mistakes? That's the important thing. How do you better yourself so you don't continue to make those mistakes? And I hope you can get that stuff from my video. John Smith, thank you very much for that super chat. He said, here's $5 not to shave my hair off. Yeah, you know, a lot of people aren't realizing that I actually have hair. Yeah, I have hair. It's kind of crazy, huh? Nearly reckless science. Oh, thank you, man. Oh, that's funny. Oh, okay. Yeah, let's do this. No, nearly reckless science says lose the hair. Is this going to be a super chat war of people saying they want me to shave or not shave my head? That's pretty funny. Thank you, guys. That was really nice of you. Let's see what else we got going on in here. All right. People from California put wings in a cooler. That's right. And we eat avocado toast on Sunday mornings for breakfast. If you haven't had avocado toast, trust me, you need to have some avocado toast for sure. So, Laska says grow a mullet. That's funny, man. You guys are killing me. Oh shoot. Dang it, I don't have it here, but I got a picture from when I was a little kid that I did have a mullet. I'll have to post it on social media. Because I did have a mullet when I was a little kid. That's too funny. Carl, thank you very much for that super chat, man. That's awesome, bud. You guys are so awesome. Thank you very much. Do I prefer working on any specific type of systems more than another? I really like what I do. I like working on remote refrigeration systems. I prefer not to work on self-contained regions. Self-contained regions are just... It's not that I can't do them. They're just kind of, whatever. I like remote systems, so condensing units located somewhere else. I like walk-in equipment with remote condensing units. That stuff's fun, and I enjoy working on that. Package units all day long. Split systems, I'm good with them too. I'm cool. I genuinely like problem solving, so it's a lot of fun. Let's see. George Robles, thank you very much, bud. You guys are awesome, man. That's exactly. You guys are amazing, man. That is too funny. You guys' super chats. This is great. I was kind of wanting a man bun. I was kind of waiting to grow my hair so I could have like a ponytail thing in the back. I wanted to be like a hipster guy, right? And do that. Someone had asked me about, actually not someone, about everybody in the world comments about how I need to install door switches on my walk-in coolers and freezers so they don't ice up so much. Guys, trust me, I want to, okay? It's a matter of getting the customers to do so. It's kind of a pain in the butt, but I think I'm making headway because a lot of my customers watch my videos and they're starting to see like, oh my gosh, we are spending a lot of money on this, you know? So, but for the comments that everybody's like, put strip curtains on. In a restaurant, strip curtains are the enemy because the cooks and the kitchen staff hate them. So they break them off and throw them on the ground or tuck them up behind shelves. So they're basically just a wasted expense for the restaurant. In a perfect world, if everybody went in a strip curtain and out a strip curtain and they left it alone, it'd be fine or it'd be better than nothing, right? But in a kitchen, these guys are just too overworked and underpaid to have to even care about that. So they just rip them off. So, Nick Castillo, thank you very much for that super chat, man. Why do I use a manifold to pull a vacuum on an RTU? Usually you'll see me use a manifold on an RTU if the system does not have normal Schrader cores, okay? If a system has Cormax fittings, right? High flow Schraders, there's not a tool out there that properly and that is vacuum rated that will depress a high flow Schrader and allow you to pull a quick vacuum through it. So oftentimes, what's the point of dragging out all my crazy hoses? I'm just going to use a manifold gauge set, okay? I prefer, when I can, to use my True Blue hoses, big hoses, take the cores out and all that stuff, okay? But until someone makes a vacuum core removal tool for high flow Schraders, that's not really going to happen, okay? Now, they do make a tool, and I have it. I've made videos about it. It's the high flow Schrader or the Cormax tool that you're able to take the fittings out and replace them, but you can't really pull a vacuum through it because it's not vacuum rated. And they do make high flow Schrader depressors, right? It's a little brass fitting that screws down and depresses the Schrader so you don't have to remove the Schrader core. Those things leak. They're not vacuum rated. They came in my True Blue kit and they started leaking right away. They suck. So, yeah, that's why. Discuss my service area. Someone had asked me, and I get this question quite often. People email and they want me to come work on their equipment because they think they're local to me. I work in the Inland Empire in Orange County of Southern California, and that is it. The Inland Empire in Orange County, and even Orange County is kind of a stretch for me. My go-to area is the Inland Empire, which is majority of Riverside County, majority of San Bernardino County, but not necessarily all of it. That's my service area. I don't go into Los Angeles. I don't go out there. I just can't. I just don't have the time. I don't have the staff or the manpower. So if I was to take on stuff way out there, then it makes it more difficult for me to make it back to take care of other things. I already answered that question. Eric is an electrician, and he really likes my videos, and he's really interested on my opinion of whether or not he should get into the HVAC side. So he's saying to kind of have a dual license and do HVAC and electrical. I mean, ideally, that is a great situation, Eric, because if you're a competent electrician, you've probably got the electrical logic figured out. Now, I will say you're going to do a little more paying attention to ladder diagrams and things like that when you're working on equipment, right? And I believe you're from another country, so you might already do some of that stuff. See, here in the United States, I work on all the electrical in my equipment. So if I'm troubleshooting contactors and different things like that, I do that. And I will replace the disconnect switch coming up to the unit, but I typically don't work from between the disconnect switch and the breaker panel. That's the electrician's job. So the electricians in my area, they typically don't troubleshoot equipment very much as they're just dealing with power delivery to my equipment, and then I handle the equipment. But yes, I really do think you should get into the HVAC side too. It will just make you a better person and make you more valuable to who you want to be valuable to, right? So I say go for it, man. It's definitely a great trade. I love it to death. I did get a reminder from my buddy Ike to talk about my Discord server. Now, let's make this completely known that Ike made me a Discord server a long time ago, and several other people have helped him to kind of build it and stuff. And I haven't been in the Discord server in a very long time. I would like to get in there a little bit more. It's just another social media platform. I'm going to post a link to the Discord server right now. I just saw... Yeah, I'm going to post a link to the Discord server if you guys are interested in going to check it out. Ooh, that is not a link to the Discord server. That is too funny. That was someone's name. So I'm going to post a link right now. If you guys are interested, you can definitely go check it out. Again, I'm going to try to make a better effort, but I don't get in there very often. There's a link. Discord is like a more organized social media platform. This particular Discord server is highly moderated. So they actually make you verify that you're a technician. So that way, you know, you fall in the right chat rooms, kind of essentially. So Discord's kind of like a giant chat room where it has different rooms inside there. They have audio channels, video channels, and then just discussions and different things. So check it out if you're interested. Let me see what else we got in here. I appreciate it. Thanks very much, Fearless Yeet. That's really cool, man. I'm reading through the chat. Looks like there's some great conversations going on. Have I used the barbecue propane that I got online? No. So those that haven't heard, I went to one of these refrigerant manufacturers that several people on social media told me that they buy their R290 from, and it's great, it's perfect, and they've used it for years. And it's the cheapest R290 you can get out there. I ordered it from this company. When you go to this company's website, it says R290 refrigerant, all this different stuff. It's very misleading. When you get the jug of refrigerant in the data stuff, it tells you it can be used for air conditioning, refrigeration, all this stuff. Follow EPA guidelines, blah, 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 right? So I figured, you know what? I'm just going to do it. I'm going to order a drum. I think it was like 10 pounds or something like that. And it comes in a normal barbecue propane cylinder, which I thought was a little odd, but okay. They gave me a little adapter to go on there. And I opened it up, and it smells like barbecue propane. So I'm asking the chat right now, what is wrong with it smelling like barbecue propane? R290 used for refrigeration does not have an odor added to it. It is like 99.8% pure, unodorized, uncontaminated, dry propane refrigerant, R290. The stuff in that cylinder they sent me smells like barbecue propane, meaning that it has an odorant in it. I'm not going to say that they didn't clean it and run it through dryers and different things, but it still has that pungent odor that is added to propane so that way people can smell leaks. That is not refrigerant grade propane, so I can't use it. So no, I haven't used it yet. It's still sitting on the side of my house. I haven't figured out what to do with it. If I have time, can I touch on the frequencies, the Manitowoc, on the frequencies on the Manitowoc ice thickness control? So I talked about it a second ago about how you need to clean the Manitowoc machines before you do anything. If you have frequencies on the ice thickness probe and or the ice thickness microphone, because that's what it is, they look at two different frequencies. I think they look at 100 hertz and 120 hertz. And the best that I can tell, I've never heard this from Manitowoc, but the only reason that I can make sense as to why they need to look at two frequencies is because oftentimes if you're standing next to the machine and you're talking while you're watching it make ice, you can look at the touchpad and you can look at the frequencies of the ice thickness microphone. And as you're talking, you'll see the frequencies go up, but only on one level. And then the other level stays relatively the same. But when the water bounces off the ice, it makes a certain sound. And that's what the microphone's actually listening for. So when that water bounces off the ice and it makes that funny sound, and that sound gets closer and closer to the ice thickness microphone, as it does that, both of the frequencies start going up. And when both of the frequencies hit like 20,000 hertz or whatever it is, megahertz, or I don't know what it is, then that's how it triggers and says, hey, I'm full of ice. It's time to harvest it. So typically those frequencies should be relatively the same. And if you're looking at a machine that doesn't have any ice on it and it's in the ice making mode, and one frequency is at 1400 hertz, and then the other megahertz or whatever, and then the other one's at 600, there's something wrong there. Either there's a weird sound causing interference with the machine, or your probe is dirty, it has water in it, and that will happen. If you ever have an ice thickness microphone on a Manitowoc ice machine, you pull it out and shake it next to your ear, you'll know if there's water in there. They used to get water in them all the time, and it just became a problem. So those frequencies typically need to be the same. Then when they hit the certain level, it's in the 20,000 range, the ice machine knows that it's full of ice, and it tries to harvest the ice. So hopefully that makes sense. Let's see. It says the invite is invalid. Cyborg Sheep, I have no idea. That was the invite that was given to me. Yeah, I'll have to see. I don't have that information, so... let me see what else we got in here. Maybe there's something wrong with the link, the way I copied it or something like that. Yeah, I don't know. That's weird. Let me see what else we got in here. If anybody wants the Discord link, do me a favor, send me an email, hvacrvideos@gmail.com, and I'll get the right link and make sure that you get that. Could you get an invite to the Discord? The one I linked says invalid. Yeah, so if you guys want a link to the Discord, shoot me an email, hvacrvideos@gmail.com, and just say, please give me the Discord link, and I'll get it after the show and get it to you guys. In my experience, what percentage of walk-in units have both T-stat and defrost controls inside the cooler compared to the units that have the defrost on the roof? Every one of my restaurants, the defrost clocks are installed on the roof or at the condensing unit. None of them are inside the equipment. I see in other people's videos that the defrost stuff is inside the equipment. I guess it makes sense, but it just doesn't work that way with me. My stuff and the stuff that I install, I always install the defrost clock at the equipment. I've just recently started installing more temperature controllers that actually have built-in defrost, which means your defrost control is now going to be down at the evaporator coil, but that was just recent. Reading through the chat right now. Again, thank you very much, everybody, for those super chats. That was really cool. Very, very cool. I'm reading up in here. See what I'm missing. Any other tips on installing walk-in coolers besides a heat load calculation? Yeah. So once, and sorry, I probably got sidetracked. So once you start going through the heat load calculation, you've figured out what size equipment that you need. The next thing that you're going to want to do, either while you're installing, is then you're going to pick your equipment. You're going to pick the evaporator and the condenser. And then when you do that, you need to figure out the refrigeration lines. Once you figure out the size of the refrigeration lines. Now, let's make this clear right now. I'm going to ask everybody in the chat right now. If you're installing a condensing unit on the roof, right, a pre-built condensing unit, and it has a 7/8 inch suction line and a 1/2 inch liquid line, okay, coming out the condensing unit, it's already pre-piped. And then you go to install your evaporator, and your evaporator has a 5/8 inch suction line and a 3/8 inch liquid line. Which line sizes do you use? I'm asking the chat. What do you guys think? Which line sizes are you going to use if the condensing unit is 7/8 half inch and the evaporator is 5/8 3/8? Which one's correct? And how do we find out if they're correct? I'm waiting. I'll wait for the chat. What do you guys think? Which one's correct? The evaporator size, the condenser size, or neither? Thank you very much, Samuel, for that super chat, bud. I really appreciate it. Let's see how far this chat is behind before we start getting answers. So, okay, Jacob D says go with the bigger ones. I want to see if anybody else has any things. Bigger is always better, Brandon. Okay, great. There's some good points and there's some truth in what you guys are saying, but I'm going to disprove some of that too. Evap for the TXV, Duffy D. Mike B says both. Fluffy Anus says the evaporator. Thomas S says the condenser. Kaylee says the evaporator. Pro C says halfway of each. Paul Dieter, condenser. Evaporator. Oh, wait. Jason Johnson nailed it. Gonna use a piping detail for proper oil return and refrigerant velocity. That is absolutely true. The condenser does not determine my line sizes. The evaporator does not determine my line sizes. Guys that answered that, you don't feel weird because you answered it wrong, okay? There's not enough information out there that people are getting that's properly educating them on how to size lines. I did it for most of my career off of what the condenser was. You know, typically whichever one was bigger was the one that I would, if it had a 7/8 on the roof, I'd run a 7/8 suction line and then put a reducing coupling at the coil, okay? I did that for most of my career. And it worked. It was all right. Until you run into weird problems here and there, okay? So the correct answer is that the refrigeration line size needs to be determined by an engineer or a technician that has the ability to figure out how to properly size pipes, okay? Line sizing practices. Old school, really old school. I showed this on something recently the other day too. This is my Copeland refrigeration manual. This is actually what I learned on when I was in school. And I don't know if you guys can see, but there's little tabs all right here. And if you look at those tabs, this is all line sizing, fitting length, pressure drop, discharge oil return, suction line oil return, liquid line sizing, suction line sizing. There's 1, 2, 3, 4, 5, 6 different steps that you have to go through to figure out how to size your suction line and your liquid line and your discharge line and your liquid drain and whatever you're doing. So the line size is based off of the line set length, the pressure drop across that length. You have to figure out how many fittings and 90s and elbows and reducing T's and different things, because that's going to affect your pressure drop. Your refrigeration lines are there to move refrigerant from your evaporator to your condenser, so that way you can have proper heat transfer. But along with that, there's going to be a little bit of oil in that refrigerant. So when that oil accumulates in the evaporator, you need to make sure that there's a proper suction P-trap and proper suction risers on the roof, and the liquid line size has to be sized accordingly so that way it can have refrigerant velocity pushing the oil through the system. There's so many different steps. It's not just as simple as using the outside or the inside. And the same exact thing goes for residential air conditioning. Residential air conditioning, you do not just use the line size that is on the condensing unit and or the evaporator. It depends on the length, the pressure drop, oil return, and all that different information. If you read the installation instructions of the residential equipment, it's going to tell you install line size this length or this size for this condensing unit and this evaporator with a maximum length of 75 feet, a maximum height, and all this different stuff of certain things. And most of the time in there, it says if you need to go beyond that, you actually have to reach out to the manufacturer, get a hold of the engineers, and they'll help you to appropriately size the line sizes, because in a long line set length, it's not completely crazy to have a line size changing sizes as it goes up a giant rise, okay? They may reduce, they may increase for different reasons, for velocity, oil return, different things like that. They may actually have one suction line coming from the evaporator, but then 2 suction lines going up, a double riser. They can have all kinds of stuff like that. And it all depends on what they're trying to do with it, how long it is, and that kind of stuff, okay? So don't feel bad because you answered the question incorrect. I was actually just talking with Trevor Matthews about this because I'm currently taking a compressor class with him that he's teaching, and I had raised my hand and tried to answer some questions during the class, and I answered them wrong. I don't have any problem with doing that, right? But I noticed that there was a lot of people in his class that seemed like they were afraid to answer. Whenever you'd ask a question, nobody would say anything. There's like 30 people in there. You know, there's only a few people that were answering, like 3 or 4 people. And that tends to happen in most classes. Don't be afraid of being wrong. Being wrong is going to make you better, okay? Because you grow from that. If someone tells you, hey, you know what? No, that's actually not incorrect. They don't need to be a jerk about it. That's not incorrect. And then they teach you how to do it. Now you know. You wouldn't have known if you didn't ask and you didn't get it wrong. So don't be afraid to be wrong. Nothing wrong with that, okay? Nothing. All right. What else we got going on in here? I'm reading the chat. Where can you get that binder book from Copeland? Go to Amazon. I don't know how easy it is. So what you want to Google is Copeland refrigeration manuals. And there's a bunch of them. I don't know if it's going to come in the binder anymore. It's probably just going to be the individual loose books. So part 5 is installation and service. Part 3, refrigeration load. Refrigeration system components. I'm sure you can download them all off the internet. Refrigeration fundamentals. System design. These are really, really old books, by the way. So don't expect them to be brand new. These are from the 80s. Well, this last revision, but I think they were probably written in the 60s and just, you know, revised here and there. So these haven't been revised in a long time. But also on the Copeland mobile app, or AE Bulletins app from Copeland, you can find all kinds of their technical documentation too. So another thing is I want you all, when you're working on equipment and you're changing components, if you can, don't throw those components in the trash. Take them back to the shop, take them back to your house, take them apart and analyze them. Right here. Really, really confusing for the light commercial guys doing restaurant refrigeration and air conditioning. When you see one of these mounted on the side of a scroll compressor, every one of you, I know, because you had to be something like me. You're like, what the heck is that? What is that funky looking thing? And why is it frosting up? What the heck does it do? And why does it look like it's going into the sensing bulb goes in the top of the compressor? Does anybody in the chat know what this is? What is this thing? It doesn't, try, just put an answer in there. What is it? What do you think this is? These things confuse the heck out of me. Laska says liquid injection. Yes, this is a liquid injection. Specifically, this is a DTC valve. Okay? This is a temperature responsive expansion valve. This is the sensing bulb. Okay? This has a definite purpose. This goes in the top of the head of the compressor. When the compressor gets hot, the gas inside here pushes this valve open and allows liquid refrigerant to come in and get metered through here. This is just an expansion valve, guys. But it's more like, it's a little different and the capacity is different. Look inside there. There's a pin and a needle, or there's a needle and a seat. And then inside the valve, there's 2 pins. It's an expansion valve, guys. That's all that this is. So I've replaced several of these in my career and I didn't know what the heck they were. They were just attached to the compressor. Look, it has a strainer just like an expansion valve right here. Look, it's an expansion valve strainer. That's all it is, guys. It's just an expansion valve. It's not that big of a deal, okay? Now, what it's doing, it's cooling off the compressor in high compression ratio situations. So you typically see DTC valves, liquid injection on low temperature compressors. But the point that I was trying to make, take them home, investigate, take them apart, cut them open. Guys, I've cut so many parts open. I just got my bandsaw out and started going crazy. Look at an expansion valve cutaway because I wanted to know how an expansion valve works. Head pressure control valve. Oh my gosh, these things right here, always bad. I don't understand why every manufacturer puts these on. It's the stupidest thing. All I do is clip the tip and bypass them and install a fan cycle control. That's what everybody on Facebook says. These things are not that big of a deal. This is a head pressure control valve. It's actually a super easy, simple concept. We have issues with them a lot of the times. Do you know what the issues? Every head pressure control valve, majority, I'd say majority, because I think there might have been one or two that might have been bad. Majority of the head pressure control valves that I've ever replaced had gone bad. Okay, I want to ask the chat, why do you think majority of these go bad? What is wrong with them? Tell me in the chat right now. So this head pressure control valve, what it does is it takes discharge gas and dumps it on top of the receiver if the ambient conditions are really low to drive up the head pressure. That's the simplest answer. There's more definition as to why. But let's see what the chat has to say. Jork, thank you very much for that super chat. Let's see. Should you go ahead and get an HVACR cert, or is that unnecessary? As a mechanitronics apprentice, electrician, hydraulics, pneumatics, PLCs. I mean, I don't know if it's necessarily going to affect you, but any education is better than no education. So I encourage you to get any certification you can possibly get because it's going to make you a better person. Now, is it actually going to work for what you're doing? I don't know about that. Alaska says the power head loses the charge. Okay. And then what does HVACR stand for? Heating, ventilation, air conditioning, and refrigeration. John L says the spring. Jackson Cook says power head. And Cyborg Sheep says junk stuck in the valve. Majority of the head pressure control valves that I have ever had failed because something simply got stuck in the seat right here and didn't allow it to close. So then it was bypassing. And why did something get stuck in the seat? What possibly could have caused something to get stuck in the seat of this head pressure control valve? Because the only thing in a refrigeration system is refrigerant and oil, right? It has nothing to do with an additive. That's not it. It's when people don't use proper brazing practices. Now, I'm not going to stand on a high horse and say I'm perfect every single time. No, I've brazed more in my career without nitrogen than I have with nitrogen, okay? So I'm not some special person. I've done it all, and I still, to this day, there's times that I use nitrogen, there's times that I don't. But understanding the repercussions of not using nitrogen is really important. You get a dirty system. The walls of that system get lined in like a carbon black buildup stuff, and it gets stuck in the system. Head pressure control valves, that will get stuck in them and won't allow them to close. The other thing is overheat situations and bad oil can cause buildup inside these valves that can cause issues too. But majority of these valves, in my opinion, fail because there's contaminants stuck in it, okay? If this head pressure control valve, all right, lost its charge, it wouldn't bypass, okay? If it lost its charge, because the charge wouldn't allow it to, okay? So it's important to understand that. Hopefully I didn't say that incorrectly. I don't think I did. But anyways, the head pressure control valves, they're just a mystery, but I encourage everybody out there to cut your components open. This is a Sporlan dryer. Shows you the difference between a solid core desiccant that's glued together or the small little desiccant beads that are floating around in some of the bullet dryers and some other manufacturers. But I encourage everybody out there, take your components home, take them apart, cut them open, learn how they work, make yourself a better technician. All right, let's get to the chat and see what we're missing here. Thanks everybody for contributing. You show up and he's talking about headmaster valves and you prime time. Man, what is it about you showing up when I'm talking about head pressure control valves, dude? And I wasn't even talking about explaining the operations, really. That's funny. They forget to put the strainer now. Okay. Got a nice flooded water-cooled unit. Cut the suction line. Swimming pool happened. Got to do a full... Oh, wow. That's a lot, man. That's funny. Y'all are funny. All right. Well, it is that time, everybody. I am going to wrap this up. I really appreciate it. At the beginning of the stream, I said, too, I'll say it again. From this point forward, if you guys want to help support the channel and you want to purchase anything from True Tech Tools, all you have to do is use my offer code BIGPICTURE, one word. There's no more affiliate links. There's no fussing with any of that anymore. All we're working off of is the offer code BIGPICTURE. So you don't even really have to email me. If there's something you want to purchase, just go to the website, use the offer code BIGPICTURE. If that's what you want to do and if you like their pricing and their selection. Obviously, do your research, and but that's just a great way to help support the channel. There's a lot of other different ways, several different ways. Just look in the show notes of any one of my videos, and it explains how to support the channel. So I really, really appreciate you. And thank you all very much. I'm going to go ahead and cue up the outro music. Remember that I go live on the HVAC Overtime YouTube channel on Friday evenings with my buddies at about 6:05 p.m. Pacific. If you're interested in checking out the show, just understand one thing. It is a completely uncensored show, okay? We are vulgar. We are vain. We're horrible people, okay? So if you like the proper and prim hippie-looking dude right here, the Overtime show is probably not your cup of tea. If you're a pretty knuckle-busting guy that likes to hang out with the guys, come over and check out the HVAC Overtime show. And that's on Fridays about 6:05 p.m. Pacific. I really appreciate you all. And I'm going to cue up the outro music. We will catch you on the next one. So my dog is not a little puppy anymore. Come here, bud. Come here. Oh. Look at this guy. Look at this guy. Look at this guy. Yeah. So yeah, he's not a puppy anymore. He's a big ass dog. All right, I'm gonna cue up that outro music. I really appreciate y'all. We will catch you on the next one.